This was astounding. It came together very quickly, like 2 weeks ago, and then they put this up, and I'm told within 2 hours, this whole room was filled already with over 200 people, and a lot of them online. So it's really super and exciting. Myself, I'm Hans-Peter Schaub. I'm a professor and chair of the Aerospace Engineering Sciences Department. And I want to welcome everybody here for this amazing, cool, fun panel and our panelists. But there'll be more introductions. My job is really to introduce the one who will be introducing everybody and moderating it tonight. So Professor Massimo Rossini is the acting Vice Chancellor of Research and Innovation and the Dean of Institutes. He's also served as the Associate Dean for Research in the College of Engineering. He is the Slade Professor of Mechanical Engineering and holds a joint appointment with Aerospace. He joined here in 2019, and before that was a professor also at Georgia Tech. A lot of administrative stuff, but I have to point out, he's also an amazing researcher. Just looking at your record, you've published close to 500 journal and conference papers. So he doesn't just do administration. He really walks the walk as well with a lot of research. So Massimo, I'll let you introduce the rest of the group.
All right. Thank you all for coming here, and welcome to CU Boulder. We're really proud and happy to have you here. And we'll have a panel conversation. So I think the best way is that each of you go around, maybe introduce yourselves, and then we'll get going with some questions, if you don't mind.
All right. Probably many of you know me. I'm Torrin Clark. I'm a professor here in the SMED Aerospace Engineering Sciences Department. Been here, I was just realizing this, almost 7 years, which is mind-boggling to me. And I was also, as we're going to get to a theme here of former CU buffs, did my undergrad here some time ago. So I'm a member within the Bioastronautics Laboratory, and I research several different things related to humans in space and other aerospace relevant environments, particularly pilots of high performance aircraft. And we'll talk a little bit more about some of the research topics throughout the panel.
Hi, my name is Anna Menon, and I am a SpaceX engineer. I am also the medical officer as well as one of the mission specialists on the Polaris Dawn mission. We're super excited to be here.
Hello, I am Kid Poteet. I spent 20 years in the Air Force flying F-16s. Yeah. And I was involved with Jared's previous mission called Inspiration 4 on the ground. And I am the mission pilot for Polaris Dawn.
Hi, Jared Isaacman. Been a pilot for some time, was on the Inspiration 4 mission that went to space in September of 21 and commander for Polaris Dawn.
Hi, everybody.
Oh, awesome. Hi, everybody. My name is Sarah Gillis, and I'm actually a graduate of this aerospace department here at CU. I'm really, really excited to be here. Woo!
Yeah.
Really, really excited to be here with y'all and share a bit about what our mission looks like and the research that we're doing in tandem with CU, which is super exciting. So I am also at SpaceX with Anna. I am a space operations engineer there, and I'm also one of the mission specialists on the Polaris Dawn flight. So handing it off.
Hi, my name is Allie Anderson, and I, like Torrin, many of you probably already know me, but I am an assistant professor here at CU Boulder in the Bioastronautics Department, and a focus area within the department. And my research also studies human spaceflight, and specifically we're looking at how the eye and the body change in microgravity. So again, get into some of that research in a bit. So thanks.
Great, thank you very much. So the way we're going to do it is I have some questions for you all. I don't have anybody in particular, so if you can pick whoever has an answer for it. And then we'll, after a few questions, we'll open it up for question and answer from the audience, and also welcoming the people that are online. And we have some questions from those folks as well. So I'll kick it off with a question on conducting research in microgravity, which is a critical mission for Polaris Dawn. And what are the driving reasons for this objective, for establishing this objective? Anybody who wants to pick? Of course.
Yeah, I think first is, you know, we all are very much believe in a world where everyone is going to have an opportunity to go into space. That's a big part of the dream that that Sarah and Anna and their team of 10,000 really smart people at SpaceX are working towards, and maybe what Starship will one day ultimately achieve. Until that point in time, going to orbit is extremely rare, right? We know how incredibly fortunate we are to have an opportunity to go into space, and we want to make the absolute most of literally every minute we have up there. So it's why we kind of, you know, cast a very wide net to solicit as many research science projects that we could potentially take on board. Have an awesome committee with SpaceXers and those on the Polaris team that we're evaluating and seeing which ones would be, you know, best suited for our mission. And we're going to keep doing it. We did it on Inspiration 4 before this. It's a big part of Polaris Dawn, and it'll continue throughout all of the Polaris related missions, truly try and maximize the opportunity we can make with our time on orbit.
Great. Thank you. To follow on a little bit, what's as the mission science program was being planned, what are the research themes that you're targeting and that were targeted?
Yeah, you know, so we, as part of this process, put out a solicitation for research across the board. And really, we opened it up across the globe. Whoever had research that would be available on a pretty fast timeline for research experiments in the grand scheme of things. Also, you know, kind of looking at what really suits the mission, what it applies to our mission, et cetera. But we put the call out and we ended up with, I think it's 23 different partner institutions that are flying different research experiments on our mission. There's close to, I think, 40 experiments that will be flying with us. But I mean, it's all of the top names in research. We're working with NASA, we're working with CU, which is a huge part of this as well. Working with Trish and the Air Force Academy, even here in Colorado as well. So overall, there's really a very wide breadth of the research that's going to be flown on this mission, as well as the institutions that are supporting it.
Great. Thank you. Since you mentioned there are CU Boulder's experiments, maybe we can talk about them a little bit more. I know there's 5 of them, so we'd like to hear and talk about them.
Sure. Professor Ali Anderson and myself are both involved with a couple of different experiments. I guess technically have 4 experiments that are involved with this Polaris Dawn flight. They're all somewhat closely related, and I'll talk a little bit more about them. But if there are more questions, I'm happy to elaborate it. I just don't want to eat up too much of the time. So a lot of what we're really interested in is how our sensory systems and the brain interpret gravitational cues as you go from here on Earth, where there's gravity, to being in space when you're in a microgravity environment. So we have one experiment that is specifically looking at what sort of unexpected or illusory sensations the crew might experience right when they go into microgravity. And we're interested in sort of understanding what are the contributing sensory systems that will be involved with that. And we have different manipulations to sort of tease that apart. Very surprisingly, this has not been something that's been systematically studied. So we're really excited to get some high quality reports on some of those sensations. And we're also interested in the reverse of that, which is what are the sensations when people come back to Earth and experience that transition from being sort of adjusted or adapted to microgravity, but now experiencing the gravity-rich environment here on Earth. So I think that will be fun for you all, right? The next one, we'll find out. So if you are in microgravity for long enough, those unexpected cues tend to lead to motion sickness. So we're really interested in quantifying the time course of that and also sort of the individual variability. It turns out some crew members experience a lot of motion sickness, other crew members not so much. And we're interested in particularly how people who have been to space before versus individuals who have not been to space before, how that affects the experiences that they have, both, again, going into space and then also motion sickness upon returning to Earth. And then the other 2 experiments we have are, one is looking at an analog. Jared touched on this, but in order to sort of be able to experience some of the aspects of being in space and going into space and returning to space here on Earth for a larger majority of people, and also for crew members before their missions, trying to develop this analog that reproduces some of the sensations that they might experience coming back to Earth, some of the unexpected cues that they experience. We're doing that through something peculiar called galvanic vestibular stimulation, which is applying very low levels of electrical current right behind the ears, and it artificially stimulates the vestibular system in the inner ear that helps us sense our perception of orientation and gravity. And we have a system where we think we can sort of systematically alter those cues so that it feels like you will feel when you come back to Earth. And so the crew has actually had a chance to try this system out. I don't know if you guys have any thoughts on this. I'm sure you can follow up. But then they'll be comparing the sensations that they had from trying that out prior to their flight to the experiences they have when they return to Earth after their flight. And the final flight or final mission, and I'll just be very brief on this one, is related to potentially a solution, a countermeasure to overcome some of the challenges that people have when they're in space for a long period of time, right? Their bones get weaker and they become more brittle, their muscles get weaker, they have cardiovascular deconditioning. And there's various ways that we can try to overcome this, but really maybe the best way to do this would be to recreate the gravity environment that is otherwise missing when you're on orbit in space. We can do that through artificial gravity. Maybe the best way to do that is on a centrifuge spinning around. But if you want to make that centrifuge small enough to actually be able to be low enough mass to be able to launch into space, you got to spin really fast. If you spin really fast and you move your head around, you get this really provocative illusion called the Coriolis cross-couple illusion that we think might be a limiting factor for artificial gravity. They don't show you that in the movies. And so we're interested in studying that. And we and other people have studied that on the ground, but in space, really this has not been well studied. And we think that the sensations might be different in microgravity space environment than here on Earth. And of course, we don't need to create artificial gravity here on Earth. We need to create it in space. So if we think this is going to be a limiting factor, we need to study this in microgravity, which we have a really unique opportunity to do so on this mission.
All right.
Any questions?
Okay. Sarah has some thoughts on those experiments, but yeah, so I'll describe the experiment that myself and my colleagues at Anschutz Medical Campus in Dartmouth are all working on together. So when we first found out about the Polaris Dawn crew and their desire to do science, one of the things that was particularly exciting is that they were interested in studying something called the spaceflight associated neuroocular syndrome. So this is a change that happens to the eye in microgravity. And in particular, it seems to affect folks who have been exposed to microgravity for long periods of time, where essentially the eye changes in space. It actually gets flattened from behind. And we have structural damage that you see to the eye itself, as well as to the nerve that goes from the brain to the eye. And it's really something that's been a big focus of NASA for essentially, since around 2011, when they kind of really first found out that this was really happening. But one of the challenges is that we don't really know how or why these structural changes are happening. And it actually causes astronauts to have their near field vision change. So they actually have difficulty reading things up close. And so one of the things that we were really excited to look at is, thankfully we don't expect these like long-term structural changes to happen to you all, since you'll be in space for 5 days, but we know that you'll be experiencing that same kind of environment. And that initial sort of change to whether it's due to changes in the fluid distribution in the body, whether it's changes to, the pressure in the eye, whether it's due to, all of these factors, it really gives a lot of researchers an opportunity to kind of study some of these changes across, 4 individuals who are kind of dedicated in helping us out to learn this. So we're flying 2 pieces of equipment in collaboration with our partners. So we're flying a device called the QuickSee, which is a device that actually measures people's refractive error. So like what prescription somebody might need. And we can use that information to back out information about how the eye itself is changing. And then we're also flying a device called the Triggerfish, which is if you're into Instagram or social media, you've seen some really cool pictures. So it's a device that has a contact lens that has an antenna in it, and it allows us to look at how the eye's cornea, the front part of the eye, changes its shape. But that tells us something about the pressure in the eye. So, this is just 2 experiments or 2 pieces of hardware that are being flown amongst a lot of other great research from other researchers who are also looking at this spaceflight associated. It's called SANS. That's the acronym for these eye changes. So.
Thank you. Any follow-ups?
We affectionately call that study the cyborg study.
Which I love it that you call it that.
The next question is for the crew primarily is how are you preparing for the mission? How have you prepared the mission to this point, and how are you preparing for it?
We have really done a vast array of different types of training. We have done a lot of training focused on the technical details of the Dragon spacecraft. So that includes book study, simulations, working together through different lecture environments to make sure that we have really the foundational knowledge of the spacecraft that we're flying in. Then we've layered on top of that a lot of different environmental experiences to help, one, build team cohesion, but also teach ourselves about our body's responses to different environments. So for example, we put ourselves on a centrifuge to experience the different sensations of a launch and reentry sequence that and experience those different G-forces so that we are mentally prepared for that experience when we get there. We went scuba diving to start experiencing those different changes in pressure environments that we will experience when we do a spacewalk on our mission. So those are just a couple of examples, but we've done a lot of those types of immersive training environments to really make sure that we are growing our physical and physiological responses to handle those environments well. As a part of all of this also builds a really strong team dynamic. And so we are introducing ourselves to really tough situations. We climbed a near 20,000 foot mountain together to really get comfortable getting uncomfortable together. Make sure that we can sit in a small can together for 5 days and go through anything, and make sure that we learn how to kind of go through those ups and downs together as a team and be able to navigate anything that comes our way. And then finally, we're embarking on really the specialized training pieces of the mission. So that includes especially the spacewalk that we'll go on. So we do training in our simulator at SpaceX is one of the things, and they have us on a kind of a system where they can lower us and move us in and out of the environment so we can practice our hand and foot placement and our in a 3D environment to really prepare every single step of the way for that spacewalk, which will be the first commercial spacewalk ever done. So anything else to add?
Any specific science and medical training that you need to have? Or you're.
Sure, I'll touch on that. So actually, Anna is our medical officer on the mission, which is wonderful. One of the things about being in the space environment is the human body responds in a lot of interesting and different ways. As Jared puts it, everybody's going to feel different, whether that's in a substantial way or a non-substantial way. And so we've gone through a good amount of medical training to make sure that we can respond to the most likely medical situations we might encounter in that environment. Spent an amazing week in a hospital learning more than I thought I ever needed to know about the human body, but really, really interesting to understand how you might adapt in this environment. From a research perspective, also with the 40 experiments that we're flying, that's a lot of time learning how to use an ultrasound, how to take measurements, Doppler ultrasound measurements of our kidneys and our livers to look at the change in blood flow through those organs, looking at the changes to the eye structure. There's a huge amount of knowledge we need to gain just to get these investigators good data. And it's been pretty entertaining as we go through and like do reviews of our learning and that. And I'm really glad that we have an opportunity to practice it over and over again. Every time we review it with people, they are a little more happy with our results, but we'll get there. So a huge chunk of our time so far in preparation has gone towards the research and the medical aspects of this mission. And then next comes some of the more specific mission objectives in our training.
Maybe just to
Go for it.
pile on to some of that, like how important the medical and the research side to this mission is. I mean, we have some experiments we're relatively hands off on. I think we've got jalapeno and cucumber seeds and such. So kind of curious what the radiation does to those things after we bring them back and plant them. But in terms of like just the medical and research side of things, like you don't really know this until you get more exposure to commercial or private astronauts. Like for all the glamorous sides to, human spaceflight, 50% of the people just over a period of time, they're going to get really sick. and not like for extensive amounts of time, but for like 3 days, you could be potentially out of commission. And then the other 50%, as Sarah mentioned, you still don't feel like yourself. And this is like the biggest factor to the whole grand objective of opening up space to everyone. Is like it sounds really great, and we want to be a spacefaring civilization and make life multiplanetary or something, but you probably not want to feel terrible along the way. I mean, imagine being on that 737, which Starship could eventually be someday for human spaceflight, and half the passengers on your commercial airline flight are throwing up. Then the other half are going to, right? I mean, and then it's just going to be unpleasant for everyone. So I think, like, for one, we can't underscore the importance of the medical officer role in the mission. I can tell you, even on Inspiration 4, you had basically 3 out of 4 crew members that were experiencing some illness that would be directly related to human spaceflight. So, odds are that it's going to happen. The training is immensely important. And then in terms of like the 40 experiments, a large portion of them directly contribute to the ability to have long duration human spaceflight, navigating through like a very intense radiation environment, developing countermeasures for these things so that you can ultimately deliver on that dream of opening up space for everyone. So I'm going to emphasize. Here you go.
You good? We talked about the CU Boulder experiments, but what other interesting technologies will be tested, and what other science experiments that you want to mention, or you're particularly interested in seeing how they turn out during the mission?
So one of the categories of experiments that we're embarking upon are experiments that really are able to take advantage of the unique mission profile that we'll be flying. So we'll be flying to the highest Earth orbit ever flown, and basically the furthest anyone's gone since the lunar missions. And so with that, you have a higher radiation exposure. And so some of the experiments we will be flying take advantage of this radiation environment. We look into pharmaceutical stability in that environment. So for example, one of the experiments we are doing is attempting to harness the ambient radiation in our environment to try to improve our medical capabilities for future missions. So it's a proof of concept study that will try to take an X-ray harnessing this ambient radiation. So it's just an example of how we can really try to take steps that will really improve the future of space exploration one day.
We're also testing plants too from our compadres from the USAFA. They have an example up there. But as mentioned, one of our primary objectives is identify what are the challenges that we're going to be faced with long duration spaceflight. And one of them is the sands that Ali talked about. And I think we have close to 6 to 8 experiments that identify that challenge of sands and how to overcome it, because it's fairly new. It's last 10 years or so that they've experienced this. And it's something that we need to overcome and understand more if we're going to venture out in these long duration missions.
Great. Thank you. And we're going to open it up for questions in the audience. And I think we need to have a microphone to walk around. I don't know who's going to walk him. We're going to throw it around. There's a lot of questions. You pick.
Hi, so we all know and love SpaceX's futuristic IVA suits. What can you tell us about the EVA suits?
Obviously, there is going to be more information coming, but generally, this suit is really the next step towards. You see the science fiction future where hundreds of people are living and working in space. And if you want to create that reality, you need to make a suit that is scalable, and that is, you can make more than 2 suits for $1 billion. Like, it's just not feasible to send hundreds of people to space without a highly scalable spacesuit. So I think some of the most interesting parts of this suit are that it is a design evolution from the existing IVA suit that now supports us in the vacuum of space. But it's, from a technology perspective, a massive step towards that future. How do you make a scalable design? How do you pick materials that are easy to manufacture and pattern the suit in a way that is really effective? So the SpaceX suit team is doing some really incredible work, and I'm personally super excited to share it with the world. But generally, it's not only technology development, just building different components to support you in that vacuum environment, but then also kind of reimagining the suit for how do you build this in a more scalable fashion.
I'm going to try to be fair and walk around many parts of the room. So I saw a hand back here.
So in the process of investigating the suits, has SpaceX looked into mechanical counterpressure at all? Or is that not something you're investigating?
In this instance, we're really looking at a design evolution from the existing IVA suit. It's an awesome technology, and I think it's certainly a path that should be explored. The suit that we're looking at is really a design evolution from the pressure suit that we have in existence already from the IVA.
So how did you guys, like, I don't want to say stumble, but how did you come onto the opportunity to become astronauts and be working for SpaceX and conducting all of this scientific research?
I guess some of it starts with me. Well, really, I mean, really starts even prior to that. Like, it took, you know, a vision from SpaceX going back 20 plus years that they could, you know, basically create this vertically integrated commercial space company. And with the idea of driving down costs to such an extent that a mission could be affordable outside of just a handful of, you know, government customers around the world, like NASA or European Space Agency, right? So, I mean, you needed reusable rocket technology to ever bring this within the realm of possible for like true private or commercial missions. And I'd been following SpaceX for some time, actually, like, have a document that contemplated what would ultimately become Inspiration 4 that goes back to 2008, when I went to Baikonur in Kazakhstan to see a Soyuz launch with some of the kind of early commercial space industry folks. It came back around with Inspiration 4, where had no idea that there wasn't, like, I thought that potentially have an opportunity at like the 100th mission, didn't know that kind of have a crack at the first. And then Inspiration 4 was really successful. And if it was, the idea that we would, you know, one of our kind of themes for Inspiration 4 was to get it right for all the other exciting missions to follow. And then Polaris is now become a lot of those exciting missions follow. And from my perspective, knowing what Polaris would be, which was very much about like a tech demonstration, you know, building upon technology that hasn't been, you know, utilized in the last 50 years or so, or not at all. And with the aim of getting to Starship and ultimately kind of achieving the bigger SpaceX dream, to me, gave like a strong indication that the next mission crew would have a like a strong contribution from SpaceX. And Polaris is very much a kind of a joint contribution from what we bring, and obviously far more what SpaceX brings to the table. And then once you kind of establish that, you know, who's you know, kind of who's going to go, I think, you know, having the lead astronaut trainer, if you're going to put tens of thousands of people in space someday, it probably makes sense in my mind that the lead astronaut trainer has some firsthand experience. And then you have a mission director there that's, you know, sees things from a completely different perspective on the ground, overseeing all, you know, mission control makes a lot of sense to me as well. And then, you know, Mr. Poteet here, Kid, was the kind of lead mission director from our side for Inspiration 4, and did a fantastic job there. Certainly earned his place on the crew.
I would recommend if each of you could describe your path to becoming an astronaut.
So I actually never dreamed I would have an opportunity to go to space. You know, I'm pushing 50. So I grew up in the 80s, the original Top Gun. The Right Stuff were catalysts for getting involved in flying through the Air Force. So I spent 20 years flying F-16s in the Air Force. I was a Thunderbird along with Stroker here, was a Thunderbird as well. Weapons school graduate. So I did that for 20 years. And then I started working for Jared. And once he started this venture with Inspiration 4, I jumped all in. Again, no thoughts of ever going to space. I got a degree in outdoor education. Spent 4 years scuba diving, rock climbing, winter mountaineering, nowhere near what you guys are accomplishing in your academic worlds. But I was inspired by what he was accomplishing with Inspiration 4. I saw the doors that were opening up with the crew that we selected. It was an unbelievable experience. I got to see firsthand what he went through for training. I got to be on the recovery ship, mission control during the mission itself. And it was an unbelievable experience. And then once discussions started, negotiations with SpaceX to plan this follow-on program, I was fortunate enough to get selected as the mission pilot, and here we are.
My journey started back when I was in elementary school, taking my lunchbox to school with my sliced cucumbers and peanut butter and jelly sandwich. And during one of those days at school, I had the great opportunity to go on a field trip to NASA. I grew up in Houston, and this field trip provided me the opportunity to experience a day in the life of an astronaut and a mission control flight controller. And that just lit a spark in me that made me want to contribute to this industry with my career. So I went on in school. I ended up getting an undergraduate degree in mathematics and Spanish because I just loved math. And then moved on to get a biomedical engineering degree as a master's. And from there, but I always carried with me this love of space and hope to contribute to it one day. And so after I finished my graduate degree, I moved on and went to NASA and served as a biomedical flight controller for the International Space Station there, and did that for about 7 years. And I loved my time there. It was fantastic to get to blend together this love for math and the human body and space all in a job. After 7 years there, I moved on to SpaceX, where I became a space operations engineer, contributed in mission control as a mission director, like Jared said, and also developing the different operations that our astronauts do in our spacecraft. So it was a fantastic joy. I got to contribute to the Inspiration 4 mission, working with the crew's families, serving as the technical advisor, sharing with them the details of how the mission was progressing, helping to answer questions, that kind of thing. And really, truly dreamed from a young age of being an astronaut, but never believed it would come my way. And when this opportunity suddenly crossed my path out of the blue, I was floored, but extremely grateful. And it definitely changed the course of my life. But I think I am really just so grateful to get to be learning and experiencing that side so that I can come back on the other side and help make future astronauts' lives better, hopefully, and contribute more.
I think kind of similarly, I grew up in Boulder. I'm from this city. I love this city. It's really wonderful to be back here now. But I don't think I had really any notion of, I didn't know there were people living in space on the space station for many years growing up. But in high school, I actually had the opportunity to meet an astronaut for the first time, and that kind of introduced me to the world of space and the possibilities that existed in the world. And I think kind of just like those cucumber seeds were flying, he planted a couple ideas. Really, what's possible? Do you want to come and study engineering? You hadn't ever considered it, but you should. And so I ended up actually coming here to CU and did my bachelor's degree in the aerospace department here. And during that time, I actually got an internship at SpaceX. So I started as an intern, and I actually was working on the human factors team. So if anybody's in the bioastro department here, it's a very real topic that you can do really fun stuff with. Doing all of the kind of ergonomic assessment, testing of the interior of the capsule. So was able to work through the last 2 years of my degree here at CU, and then eventually transition to full-time once I graduated. When I started, I joined the training team at SpaceX, and that was really focused on the training the the operators in mission control. We were working on Dragon 1 at the time. We didn't have a crewed vehicle. So it was really training the ground controllers. I was able to become an operator. I was a navigation officer also for the ASN students here. Awesome. And support and mission control as an operator. And then when it was time to build our astronaut training program, because we were building this vehicle that needed crew to fly in it, but we had no training program, they were like, well, you know the interfaces and you worked with the spacesuits, so let's go put the training together. So got incredibly lucky at the birth of this program and helped to develop our astronaut training program at SpaceX. So it's been a really twisty road that got me here, I would say. But couldn't pick a better crew to fly with, and really am mostly just looking forward to bringing this knowledge back and sharing it and seeing the entire process from the other side. I've trained all of our crew members so far, but actually getting to go through the process and see what we can bring back to better the future training for all of our crews. So.
Thank you.
Hello, Jared, since you're the one who has done this before, could you describe a little bit what the inside of a Crew Dragon is like as a living and working space, like what the sounds and smells are like and what the sleeping arrangements are and how you handle all working on different experiments in this one room?
Sure, there's a lot there to it. First, I'd say it's a lot more spacious than you might imagine. It's interesting when we're here at 1G in the simulator and you're like, wow, this feels a little cramped. It really goes away entirely in space when you have all that vertical volume to work with. We actually almost literally worked on 3 levels. So, kind of the cargo area became its own area for, different work, and then middle and then kind of upper. I think we'll maybe have a little bit less room now without the cupola. That did add some habitable space to the vehicle. We won't have that on this mission given the EVA. Sleeping in space is interesting. So before I went up, we spoke to a number of astronauts and they, share some of their knowledge and experiences, and generally was half like it, half don't. If you sleep on your back at night, you'll probably really enjoy it. It might be the best night of sleep you ever had. If you kind of are a side sleeper on your stomach or enjoy any sort of cocooning process, you're not going to like it. And I'm like, you sure that's 50-50? Because I'm definitely a side sleeper in it. And you don't enjoy that part because there's nothing you can really compress around you. You inevitably just wind up, when you're falling asleep, just turning into a board and floating. And yeah, I mean, you're going to go everywhere if you don't say so. I'd say it smelled actually quite fine. In fact, it kind of almost reminded me of a if you go to a YMCA, that chlorine smell of a pool. But it turned out that was actually unintentional, that there was a leak of a chemical that apparently was harmless. I don't know if they volunteer otherwise, but and then sounds like there is quite a bit of a persistent called white noise, a lot of fans and pumps running, and then periodic Draco firing. So Dragon is always very alive and talking to you, which is great. So hopefully everything was driving. So it's pretty incredible vehicle, very spacious from spacecraft standards. Great vehicle.
In terms of research area, one of the experiments, you guys are going to be flipping each other heads over heels and hopefully not hitting heads on anything. I know you practiced that a bit in parabolic flight. You guys want to elaborate upon that experience?
It was great. We, our wonderful team at SpaceX created this, this volumetric simulation, simulated space in our parabolic flight out of PVC pipes that we rapidly put together when we got out to the straight and level portion of the flight to basically simulate that 3-dimensional available volume in our spacecraft, because we were nervous that we weren't going to have enough space to do this head over heels spinning and at the right pace that you need to make sure to get the right provocative motions. So we set it up. Jared and I were spinning some wonderful teammates, and very rapidly we realized that all 3 of us couldn't control our bodies at all, and so all 3 of us start drifting in 3 different directions, and the PVC pipe starts to explode in a very slow Matrix-like moment. but we were able to visualize what that environment or what that volume looked like. So then on subsequent parabolas, we were able to actually achieve the right spinning rotation rate, and we're able to control the spinner sufficiently to get confident that we can actually have the right space and the right success for your experiment in flight. Anything to add?
So as pilots, you demand and expect a high level of control in your aircraft, really when it comes down to stick and throttle. But when it comes to spacecraft, we're now increasingly seeing that being shared, some might say taken away by automated and autonomous functionality. So with that in mind, where do you see the role of the astronaut in the cockpit in the next 10, 20 years?
Well, I mean, so I think a lot of the flight time, well, certainly probably more of my flight time than yours, the autopilot was on. I think like, 99.9% of flight time, certainly commercial now is, you wheels up, you're pretty much putting the autopilot on, and geez, even most commercial airlines now have auto land capability too. So you could almost essentially leave it on throughout the flight. I totally acknowledge it takes all the fun out of it. That's why we fly other airplanes that don't have autopilots on them. And Dragon is certainly no different in that regard. Like, I mean, incredible vehicle and a lot of autonomous capability built into it. It does have a lot of manual capabilities too, so that if something does go wrong that's unforeseen, that you can have means to come home safely. But I think for sure, like the kind of the right stuff days of test pilots, bring a lot to the orbital space flight is becoming less and less significant. And what's, in my opinion, much more significant is you need a lot more medical professionals. Like I said before, if you're adding hundreds or thousands of people in space, there's hundreds and thousands of people that are going to be sick in space. And you're going to want to be able to treat them. Plus, I mean, long duration, cracking the code, like nobody's done surgery in space. You haven't, given birth to children in space. All these things would very likely be a reality when you start talking about an enduring presence on another planet, for example. So in any case, like I think medical professional field, I think really, talented engineers that can fix stuff. Right now, Sarah and Anna, when they're not traveling in space, they're working in mission control. There's a lot of control that's happening here on Earth that when you have 20-minute transmission delays is probably not practical for, solving problems. You're going to either hopefully build it into the vehicle's capabilities, or people there are going to have to fix things. I think those are more roles. But that just final point on like aviation, I would say like if you have an aviation background, your ability to adapt to like the displays that SpaceX has built in the vehicle is like it's very intuitive. It comes to you quite naturally if you can leverage some of that knowledge. You can still have attitude, direction indicators, how your altitude tapes, airspeed type tapes are all pretty common.
I'd say just to pile on to your question, coming from fighters, yeah, I have a control issue. I want to control as much as I possibly can. But there is a lot of continuity. The direction we're going, the evolution of space travel, it's autonomous. It's the natural progression of most machines. But I think there is a lot of carryover from flying fighters and flying other types of aircraft that are applicable. Just the situational awareness, maintaining sensor management, understanding the information and how to interpret it and communicate it, not only to your crew, but everyone on the ground. So I think those skill sets are still applicable and they will be in the future as far as spacecraft are concerned.
Are fighters becoming drones?
Hope not.
Hi, I was wondering for a private mission, what, if any, NASA safety oversight is there? We work with JSC safety and it's cumbersome and onerous sometimes. And do you have a similar safety board and review process for your experiments? Thanks.
So one of the really, really cool aspects of the commercial crew program when they were working this contract and how it was developed is that NASA really helped us build the structure and the system and the processes that allow us to build spacecraft and develop our operations. And the way that we're building out the new capabilities for this mission are no different. They're working in the tools and in the framework that we've had NASA help us develop along the way. So from like a development perspective, we're still working in the exact same way we operate with our NASA counterparts on a NASA mission, or within the systems that they have set up to help us. But then additionally, we do have external partnerships that are in place that we can leverage all of the incredible work that NASA has done in, say, the EVA realm, in these operational areas that we don't have any experience with yet. So we're absolutely leveraging the information that they have and working with our counterparts there to certainly not go backwards, make sure we aren't missing any lessons that have already been learned the hard way. And we do have, you know, kind of equivalent parallel boards of coming in to review what we're doing across the board. So certainly very appreciative of the role NASA has played in helping to develop the Dragon spacecraft overall and develop the capacity to fly humans, and are learning everything we possibly can from them in the process.
Hi, thank you for talking with us today. My question is, as we put busloads of people into space, how will like ground training start to change? I imagine not everyone is going up in Jared's MiGs for every flight.
I can take that one. So I think it's only natural that currently you have a small set of tasks that everybody needs to perform. And so everybody goes through that training. When you start looking at, say, 747 of people flying, you have a flight crew and you have people that are really well trained on specific skills. You have your stewardesses, you have your pilots, but then there's a lot of passengers as well. So I think in the future where we're sending a lot of people, we just need to break down what the skills are that are needed. And you're going to have your engineer, you're going to have your medical doctor, you're going to have a commander of the vehicle, but their designated roles and their training is what's required for that role. Not everybody is going to be able to do everything on the spacecraft, but they don't need to. You only need the one person that can do that task. So I think there will be certainly lots of passenger seats, and that's okay. You can go to space and you can have somebody else take care of your medical needs, for instance. So I think it's just kind of spreading out the workload.
Yeah, I mean, there's literally no one better to answer the question than Sarah. She's trained every crew that's flown on a Falcon and Dragon into space. And I think that's part of it. Is it's a Falcon and Dragon. You're training people for the vehicle. And the vehicle right now has four crew members, and there's no one else to help each other if throughout the duration of the mission. Somebody's not feeling well, that's like a problem for all four of us. We all need to help. We need to help make sure that we have like happy and productive crew throughout the mission, so we can accomplish all of our tasks. And so that requires like a great, team bond across us. And so a lot of the things outside of the academics or the simulation training, whether it's climbing mountains, I mean, flying fighter jets is a great way to, expose the crew to, G-forces outside of a centrifuge, but it's also like a high consequence, dynamic environment where, you still got to be able to, perform even if you're under like, strenuous conditions, right? And I think that's like imperative while we're flying a Dragon, that, there's no just, off switch at that point in time. One crew member is like really unhappy. I just want to come home. That's not a choice. Like it's incredibly dangerous. Like everything about it is still as glamorous as it is. It's super dangerous. You're going 17,500 miles an hour. It takes a rocket with 1.8 million pounds of thrust to put enough energy to put you into orbit. And then you got to take it all out when you come back home. So somebody having a bad day up there, doesn't have that vote to say it's over. Like all four of us are kind of in this together, but that will change. And when it does change, then the training associated with it should change. To Sarah's point, you build a starship where, look, there's 6 people that have to have that, I'm just hypothetically, have to have that, team cohesion, that, ability to persevere, even if it's situations become very uncomfortable or whatnot. They know their role and functions to keep everybody else safe. Totally reduces the training responsibility on the other, 94 people. Maybe they don't have to fly in fighter jets. They certainly should be exposed to hygiene environments. And, they probably don't have to go through medical training or, to the extent of the same like fire response training that maybe a crew member would. So I think it all relates to the vehicle. And as SpaceX designs vehicles that, are meant to carry lots of passengers and not crew members, then I think the training program associated with it changes. And not everybody needs to go up in a MiG or something.
I was wondering if y'all had favorite experiments that y'all will be doing or most interesting to y'all personally. Yeah, no pressure from the professors.
Yeah, maybe we can all answer that one. Gosh. I think from just the benefit of and the novelty of not having ever seen this data before at the initial transition, I frankly do think the cyborg study is super cool. We've historically, yeah, historically, to get measurements of your intraocular pressure, you're taking a little probe and you're like basically tapping the eyeball and you get a discrete data point. But that doesn't tell you anything about the time history of how your body is adapting, how the fluid in your body is shifting, and kind of the time profile of that fluid change and your vision changes. So getting kind of early transition data is something we've never done before. I can't say I love the contacts, but it's just like such an interesting data point that does stand to benefit our knowledge and what's happening and what causes SANS. So I find that really cool. Yeah.
I mean, I know I'm speaking for every single one of the investigators, but we are so grateful that you all are so excited and invested in the research, and especially my experiment. So
Yeah, I mean, I don't necessarily know if I've like one particular favorite, although I do think the idea of just the natural kind of radiation environment we're in, being able to hold up our hand and taking an X-ray is fascinating and terrifying at the same time. I mean, that'd be like really, really strange, right? Just hold up your hand and put some film behind it and see if it actually shows your bones. But like, I mean, very important when you think about what is going to be your diagnostic tools. Your, mass is like a very huge deal in human spaceflight. Putting a CT scanner on a spaceship is probably not very practical. I honestly I find them all really, really fascinating because there just hasn't been much of this, especially relating to like human physiology as it relates to long duration spaceflight. You really believe in that dream of potentially putting, a colony on another planet or a lot of people in space, like to be able to be, happy, healthy, and productive through it, and come back home to tell about it, is I think pretty important. And throughout human spaceflight, first, there's just not a lot of it, really, when you think about it. Not a lot of, only 600 or so people have been into orbit, and a lot of data isn't available from it either. So you got a lot of government workers with privacy considerations also want to fly their next mission too. So information isn't always available. Whereas I think thankfully with commercial spaceflight, there's just like, I think, an overwhelming willingness to share information and take these things on so they can chop up as much skin as they want. We've already done some of that, donate, saliva, other great bodily fluids to learn as much as you can from it to really make this dream open for everyone. So I'm all for literally every one of them.
I'd say if the plant experiment was more interactive, I'd give you some props because obviously it's very important. Everyone wants fruits and vegetables, cucumbers, tomatoes, pineapples, jalapenos on orbit, because that's one of the challenges that we're faced with is food. Thankfully, 5 days we'll be able to solve it. But with the astronauts on the ISS, 6 months, long duration space flight, it's going to be more of a challenge. So we appreciate your contributions. But I would say my favorite experiment so far has been the airway assessment that Ann and I have been executing on these guys, where the endoscope, yes, goes down the nose and assess the airway, because that's all important stuff is to figure out how we're going to triage when we are on orbit. It's the basic necessities to sustain life. She's working on a CPR type of experiment. So all those are important, but as far as applicability and fun, It's the one that the airway assessment that we're working on.
I would definitely echo my crewmates that I truly love all of them, and I feel very grateful to get to do such a suite of research while we're up there and really make every minute count. I think the biomedical engineer in me really particularly loves the ultrasound experiments we're doing. So we are flying a couple different portable small ultrasound devices that can connect to either a tablet or a cell phone. And these, we can use this for both like medical diagnostic things. So if you have like bladder distension in space, things like that, that are really common occurrences in the space environment, you can use it for medical needs, but you can also use it for a lot of great research. And so some of the experiments we're doing involve measuring the optic nerve sheath to better understand that SANS issue that have been studying, NASA has been studying for a number of years. We are measuring the dynamics of the blood in the liver and kidneys to better understand how our pharmaceuticals break down in the body and how our bodies are able to use it so that we can understand if they will work for us the way we want them to when we need to lean on them in space. And then we're also testing out some just-in-time training techniques with these ultrasound devices. And these techniques can really, if you think about going to Mars one day, you're gonna need to lean on things like just-in-time training to be able to do all of the different medical procedures that you might need to do. And so hopefully we can learn a lot from this just-in-time testing that we are doing to better inform future spaceflight.
The way we're doing that is so far Anna and Jared have gone through those procedures and Kid and I are ignorant to them. And so when we get close to flight, we'll get like some very quick training right ahead of the flight. And then we'll be able to compare results as to how we perform just reading a procedure and seeing if we can actually get real data from the ultrasound devices. So it should be fun.
Sarah, thank you for taking that question first. Hometown pride, go Buffs. Next question.
I obviously have a multitude of questions, but I will stick to one for now. So with the emphasis on studying human physiology in space for this mission, have there been any discussions along the way and experiments that relate to different health conditions and different impairments of different people? Because obviously spaceflight has been rather barred by a necessity for certain health conditions, like certain physical capabilities in the past. Obviously just due to circumstances, but I was just wondering, as the purpose is to start to allow more people to go into space, obviously as passengers and things, has there been any emphasis on trying to figure out how people who might have a spinal cord injury or missing limbs or might have some sort of like heart defect might react to that space environment?
Absolutely. I think that's what is so cool about the future of what we're trying to do is expand access to space overall. On Inspiration 4, Haley Arsenault was the first person to fly with a prosthesis. And that's something we didn't quite know how to solve, but you look at the problem, you figure out if there are any modifications that need to be made. But frankly, for anybody that has different types of disabilities, the space environment allows you to live in a entirely different way. So figuring out what we can do to expand access to more and more people is super important. One of the studies that we're doing on our flight is we're actually going to be wearing glucose monitors for the full duration of the mission, with the intention that, about 10% of the population is diabetic. That shouldn't disqualify you from flight as long as we can understand and make sure that you can handle that well in space. So absolutely, I think it's an amazing avenue for people that there are so many possibilities. And I think that's also something that SpaceX is like super on board with, is figuring out how do we expand access? What can we provide in different ways to support more people?
If I'm just layering onto that a little bit, it's almost in my mind, understandable when you look at NASA and, they get 1 million applicants. So, and they're all amazing individuals. Like how do you come up with the screening criteria? So they come up with, essentially you got to be, perfect human specimen in order to do it. But that was like a screening criteria. It doesn't necessarily mean you can't perform or be like, a fantastic crew contributor in spaceflight, right? And I think like now, really thanks to SpaceX and, you know, again, the technology they've helped pioneer to open it up for commercial missions like Inspiration 4 and Polaris. Now you're forced to think through things that wouldn't have, you know, necessarily been requirements from, you know, through NASA. So for example, in Inspiration 4, one of the ways, well, first of all, I would say like, I think like probably all 4 of the Inspiration 4 astronauts, if they were going through the same medical screening as NASA, would have been disqualified. I mean, there were, you know, there was minor heart related condition there. Obviously, you know, Haley Arsenault has a prosthesis. So I think idea just showing already that those limitations that have already been established are not, like they're just, you know, they were arbitrary and not like really a true limitation for human spaceflight. I think that's already been dispelled in a lot of ways. But one of the things I liked is one of the crew member competitions to be on Inspiration 4 involved kind of making a video and went through a, you know, somewhat of a, you know, social media process and others to evaluate. Well, one of the applicants in that came down was hearing impaired. And I remember, you know, when bringing that to SpaceX as a value, I mean, you know, she didn't win, but it had nothing to do with being hearing impaired. They went in and looked at it and was like, well, this is awesome. Like we never would have looked into what, you know, what changes we might want to make to the vehicle in order to, you know, adapt to a crew member that, you know, that is hearing impaired and just totally leaned into the challenge on it. So I'd say like, you know, Starship's successful and you start opening up space to, not 14 people on orbit at one time, but like hundreds or thousands of people. You're going to have all sorts of folks going into it. You have an organization that's kind of leading the charge right now that like embraces those kind of challenges, gets excited about the idea of how they can continue to, make space an environment for really everyone. So anyway.
I was just wondering what you think the future of like reproduction in space is going to be and how we're going to do experiments on that.
Well, honestly, I think we all dream of a world where there will be people living on Mars. And so I think one day there will be people reproducing in that, that environment of space, different planets, microgravity. I think as we continue to expand the people that can go to space and are able to take families one day, I think that over time, this won't be such a novel idea. I think the goal is that this is actually just part of the norm, just like, you bring your family or your loved ones onto an airplane today.
I will take this. Just to pile on, that's why we've identified 40 experiments. Science and research is to help solve some of these challenges that we're going to be faced with these long duration missions. I mean, going to Mars is like 9 months-ish. So, by the time you get to Mars, but then you have your duration on Mars and then the return trip. So that there is, these long duration missions, there are these challenges that we're faced with that we need to solve. And that's why we've identified the science and research that we have is to help continue to solve these challenges.
I think just to continue pile on to this theme, right? Like, I just think this all just screams like opportunity, not directly the reproduction one, but in general, right? Like I think like, a lot of people talk about, I've spoken about like, how do I work at SpaceX one day? Like they're putting people on Mars and it's like, I don't know a better organization. I mean, they've, again, most talented people I've ever come across. They've got one problem they're working on solving right now, like building a reusable launch vehicle that can take people to Mars. There's a ton of other shit we got to figure out if you get there, right? And yeah, sure. What happens when a child is born in reduced gravity environment? What does that set them up for? And is this like an evolutionary step going into it? But even the whole medical process associated with it, not even a minor surgery is done in space, let alone like a cesarean section or something like that. There's the psychological aspect of, it's not a blue marble like when you're looking back from the moon. It's a blue tiny little speck, and you're not 2 days from coming home or 24 hours from coming home from space, like on the space station. You're 6 to 9 months from coming home if you're, something's going wrong. So I say all this because you're you're all, you know, pursuing an academic path in aerospace. Believe me, there are, like you identified one of like a million problems that are like real problems that people are going to have to put energy towards in a number of fields. If we think the idea of making like a sustainable population on another planet even remotely possible, like SpaceX is like working to crack the code on one element, the transportation measures to get there and back. And there's so many other things that have to be figured out along the way, or it'll be a big Lord of the Flies event.
So you talked a lot about like the technical training and the scientific training behind this mission. Can you talk a little bit about any psychological training that you've received and what mental health looks like in space and going to space?
I mean, just kind of layering onto the way I answered the last one, like this is another problem that you gotta figure out. I mean, I think, you know, one area, at least at this phase, like I don't think there's any kind of compromising on like meeting certain, you know, kind of, I don't know, I guess psychological standards right now versus other aspects of you know, health evaluations, that it's a this incredibly dangerous environment up there, right? I mean, there's probably like an obvious like claustrophobic element to it that, you know, if you are claustrophobic, you probably shouldn't be in a Dragon space capsule for a period of time. But again, like I think there are no real analogs here on Earth. Like you can lock people in a shipping container for 6 to 9 months and say this is like, and you know, it's not the same. Like you know exactly what's underneath you at this point. It's Earth. If there's a problem, you can exit your shipping container. I don't think Antarctica is a very valid analog to any of this. I don't think crossing the oceans during the, you know, first stage of exploration is remotely applicable. I don't even think the moon is applicable. You're 2.5 days from coming home from it. I think like you're talking about psychological stressors that we have never even come close to trying to simulate here, being really 6 to 9 months away. I think like, you know, you cross the ocean in the 1400s because whatever, whether it's for, you know, religious freedoms or national pride or anything else, like you're going to arrive at a place where there's water, there's fish, there is wood to chop down to build something. If you work really hard at what you're doing, you might be able to build a bigger house using wood. You know, like this is, none of these things are applicable. You're probably going to live in a dome and you can work really hard and you're still living in a dome. And you're probably, so I think the bottom line is it's an area that has to be figured out extensively. I'd say throughout human spaceflight history, like it's not a flawless record at all. And you're talking about some of the most highly screened individuals imaginable. Like this is something that, again, is one of many things that like is going to require research and understanding to figure out in order to, you know, ever, you know, kind of fulfill the notion that you could have hundreds or thousands of people in space or on another planet.
Maybe more specifically to our mission as well. A number of the analogs that we're putting ourselves through are really intended to kind of practice exercising that muscle, putting yourselves in uncomfortable situations. We've done scuba diving. We've done the centrifuge training. We've done vacuum chamber testing, and we're going to do some skydiving. The more you repeat working through a situation that's really high stress, the more you can expand what you're able to focus on when you actually go through that. So it's certainly a big part of our mission to prepare for the EVA operation that we're going to be undertaking, but also to see each other go through uncomfortable situations and figure out how we support each other in that. Because you can't always get yourself out of that situation, but you need your crew members to know that you're there and that how they can best help you. So we're certainly, it's intertwined with our training, but there's absolutely psychological training that goes into it.
I actually want to ask a follow-up because I know that, you know, one of the additional challenges is the lead up period and just the huge amount of time you're investing for yourselves personally. And, you know, I'm sure that your family and friends and loved ones, you know, kind of notice that as well. Can you speak to, you know, how that process has been for you to really kind of like find that balance for this sort of like once in a lifetime opportunity, but also trying to deal with all the other things that life is throwing at you?
We can maybe pass this around if other folks have opinions. I don't think that I could have imagined what this entire process would entail even last December when I found out about it. I think it's also something that we're continuing to learn and figure out as we go. Anna and I are still employees at SpaceX and we still have day jobs. And so this is a part of our job now and that's wonderful, but there's also still work and there's spending time with our families. So it really has come down to figuring out what are, for me, my biggest priorities, and that's going to be spending time with my family. But figuring out how to adjust and balance that is certainly an ongoing conversation.
It's certainly been challenging. If you had asked my wife 2 years ago before any of this exposure with Inspiration 4, she would have said, hell no. But she was right there along the way, watching the Inspiration 4, got very familiar with the team at SpaceX. So she's more accepting now. There's certainly challenges associated with the risk involved that Jared has highlighted with any type of space travel. It's there, it's real. I got 3 kids, I still got a life at home. We got to, deal with the challenges of family. I got a 17, a 15, and a 12-year-old. So they're all excited. But, to be real, it is challenging. You got to find that balance of giving time and energy and effort towards that family while staying focused on the mission. It's certainly ramping up. Our training's starting to increase. We're inside of 5 months now from launch. So it's working that balance, and it's important to keep, all the priorities straight to include family.
Yeah, I would echo a lot of that, and that it's been a constant learning experience. I think, something that SpaceX has taught me is the value of iteration and rapidly being able to adjust. And so I think, honestly, I have been applying that to this like balance of how to navigate, making sure to spend the time with my loved ones, as well as, pouring myself into the day job at SpaceX, and as well as like making sure every ounce of our training gets all of the attention it needs. I have a 2-year-old and a 4-year-old at home. So I cherish the time that I get to be at home and be with them. And I think, one of the techniques that I have used is I journal a lot. And so, I try to be present in the moment, and I journal the moments when we're in training, and then I journal the moments I'm at home and the kid says a funny thing. And I think, but it's never perfect. It's always adapting, and it's always continuing to learn from a good moment or a bad moment, and trying to just improve every day.
Okay, we are
Follow up
closing
on-
in on about 10 minutes. Massimo, did you?
Just had a follow-up on high risk and high stress situations. Do you have any methods that you adopting or that you've learned during training to handle these situations? That was a tough one.
I mean, I run a public company during the day, so jumping out of airplanes and flying fighter jets and like that's all welcomed, man. I can't wait to get off this planet sometimes.
Psychological.
Come back. I mean, I think like we've done enough simulations, spent enough time together in very stressful environments. I mean, being able to kind of compartmentalize, right? Like there's always something going on, right? There'll be things going on in our lives every day. There'll be things that are left open before we launch into space that we'll still be thinking about. And I think, when you get into the, various situations, especially like the dynamic environments where things can go wrong very quickly, is being able to put all that aside, really compartmentalize it and focus at what's in front of you, and try to always be ahead of the situation. In flying airplanes, it's always being ahead of the jet. It's thinking about what could be coming next and anticipating it. And you don't have to waste too much brain power on the stuff that's supposed to happen correctly. That's good. You just continue to think about all the things that can go wrong. And that way you're just really, prepared, well timed to respond to it. And like, I think everybody's, we found lots of good ways to practice that here on Earth, and we do it in simulations so that we're really, kind of properly tuned when we go into space.
Maybe we'll take one more.
Yeah, is there any striking differences between like working with a government funded space program and a privately funded one?
Can't get in trouble for answering this, right? They're both equally fun.
Yeah, I mean, I think they are inherently different in some ways. When you are working with, say, the government, there's inherently institutional inertia. And in some ways, you just have to work through the process and it's going to be a little bit slower, and that's okay. When you're doing a commercial mission, you maybe don't have that inertia, but at the same time, you need to slow down and make sure you're doing things correctly. And so a huge part of what we do is we can design quickly and iterate and get to the right solution quickly. But then when we get there, we stop and we go back and review everything and make sure we're double checking and triple checking what we do and the decisions that were made along the way. So I don't know if it's faster either way, but the time allocation is maybe a little bit different for how and where you spend the energy. You can move much faster at first, and then you need to pause and you need to go back and you need to review. So I think that's maybe one of the striking differences is just a different allocation there.
I can't get in trouble, so I'll pile on. You know, coming from the government, Air Force, military, and then witnessing what I do watching SpaceX, it's a cultural difference. Part of it is generational, but I am so amazed by the men and women of SpaceX, individuals like Sarah and Anna, and guys and girls like you guys who are going into this industry, or, you know, whether it's aviation, space. I am amazed every single day we go to SpaceX of what they're able to accomplish, you know, and you know, no hit on Space Force or Air Force, but for the government to accomplish what they have and how they continue to lead this industry, you know, they're the ones taking astronauts to the ISS. They're the ones launching a rocket every 6 days. We're not seeing that out of the government. So, and it is a testament to the men and women of that organization that is so impressive.
Just to add one more thought, I think that with every partner that SpaceX has, we actually learn things. I think there is a push and a pull that happens with NASA, and there's a push and a pull that happens with our commercial partners. And I think that team experience is actually good for us all around. I think we learned a lot from NASA. We continue to learn a lot from NASA, and we continue to learn a lot from our commercial relationships. And so, you know, I think that when you put a lot of different and great brains together, you can actually achieve the best things.
If I can not pile on that, because I can't speak at all to differences, but I can speak a little bit to the sort of research scientific experience that we've had as part of this mission. There's sort of a few unique things. It's been incredibly rapid, right? Like it's been less than 1 year between when we started having some conversations, put together some ideas, to when this is going to fly, right? Which is like unheard of, right, for spaceflight experiments. And that's been really pretty incredible. And I think that has happened because it's been really collaborative, both with the crew, but with lots of the SpaceX collaborators that we have been really proactive of, you know, sort of seeing the vision of maybe what the experiment is intended to be, but being pretty realistic of like, all right, here are the constraints, and we're trying to do 40 experiments in 5 days. So what if we try to combine these 2 tests that you have, or do we have to do this part? And it's not always necessarily reducing the experiment scope. In many cases, it's been being approached of, hey, this other investigator is thinking about also doing this test. Would that be useful for you? And I think it's been really promising to get the maximum amount of scientific return on the incredible opportunity of being able to do some experiments in space. And so I just really wanted to emphasize that, because it has been both incredibly rapid, but also just the opportunities that we've been given to test out some of the stuff that I mentioned pre-flight of, hey, what if in 4 days you guys came out and tried out your system with the crew, and we were able to send 2 of our lab group members out there to test it with the crew, and all 4 crew members were super excited to try it out. So this has, I think, been a unique experience from that perspective. But again, I can't compare directly one-to-one a comparison there, just sort of commenting on my experiences.
Well, I think we can wrap it up here, and I just want to thank you so much for spending the time, for inspiring research for our people, and for leading the way in so many directions that are related to space flights and to the future. Really, you're defining, not only you're solving problems, but you're defining the problems of the future through this mission and through our collaboration. So thank you for coming and for inspiring us and for spending time with all of us tonight. Thank you so much.